And one of the things that we want to do is continue to serve communities. So we tackle some of the toughest problems, things like pharmaceuticals in wastewater.
This product was started, developed for the founder's father. Okay, so PFAS, I'm hearing a lot about it, especially around the conference here. Everyone's talking about it.
There are over 4,900 PFAS compounds recognized by the American Chemical Council. If you actually take what the EPA is looking at in the wastewater as a total absorbable organic fluorine.
What makes it safe?
It's an iodated compound, and we wanted to exploit that polarity. So there's a few of us in the industry, but not many right now. There's consumer product bans in some states. 3M has actually announced that they won't make the polyfluorinated compounds anymore after, I believe it's like 2026. So BioLargo is an innovative clean tech company.
You're giving our ideas.
Yeah, absolutely.
Here with Tanya Chandler at the BioLargo booth at WEFTech. Thanks for walking us through everything.
Oh, we're happy to help.
Can you give me just like overview, what is BioLargo?
So BioLargo is an innovative clean tech company. We specialize in making life better. And one of the things that we want to do is continue to serve communities through innovation. So we tackle some of the toughest problems, things like pharmaceuticals in wastewater, PFAS in water and wastewater, tough odor control issues. We want to help communities solve those issues to make life better for their community.
That's well put. How did you guys get started?
We had a chief technical officer now who was an innovator, and his dad actually was in a nursing home and was having issues with things like bed sores and issues with odors with the diapers and things like that. So he wanted to come up with a non-toxic technology that would help his dad. Well, that evolved into our actual odor control technology that has served the solid waste community for about, I believe, 10 years. Now we're introducing it into the wastewater community. And then our engineering group came about. They bounced around through the industry following acquisitions. So at one point in time, they were Shaw Environmental. They became Chicago Bridge and Iron. Chicago Bridge and Iron imploded due to a lost lawsuit. And 13 of their engineers were helping us on a project. And my boss said, "What are you going to do now?" And they said, "We don't know." And he goes, "Let's start an engineering group."
Oh my gosh.
So that's how we got our engineering group. And in 2019, that engineering group actually answered a call for innovation from the EPA on PFAS removal technology, and our AEC was born.
Wow, that's pretty cool. So essentially there were a bunch of guys that needed work, and
Yep.
Well, they liked him and just
Oh yeah, they worked great together, and they wanted to continue it, so they continued it.
continued it. Okay, so PFAS, I'm hearing a lot about it, especially around the conference here. Everyone's talking about it. Well, can you kind of give me a brief overview why it's so important?
Okay, there are over 4,900 PFAS compounds recognized by the American Chemical Council. They are per and polyfluorinated alkaline substances, okay? Now, those are big words.
Yeah.
Basically, there's 6 of them that we need to worry about right now with the regulations, but it's not going to stop there, okay? Coming up, we've got circuit regulations, meaning Superfund. We got RCRAs coming in. We've got drinking water. We've got wastewater. All of them, and even air quality, is all going to eventually be regulated for PFAS compounds. If you actually take what the EPA is looking at in the wastewater as a total absorbable organic fluorine test, then you're looking at about 15,000 compounds that are going to show up on that actual test. So this is a big problem in the industry. There's been a lot of collection techniques, traditional things like activated carbon to remove it, ion exchange compounds, membranes. They will all take it out, but they won't destroy it. So then you're worried about, what do I do with that waste destruction? So enter in some of the technologies like supercritical water oxidation, things like the Hull systems, some of the incinerators that can go up to over 2,200 degrees. That's what you're looking at for destruction technologies, but we wanted to take it in a different direction. So what we did is we created the Aqueous Electrostatic Concentration Unit, because PFAS actually are polar, and we wanted to exploit that polarity to create a better removal process that did both long chains and short chains, because a lot of the technologies struggle with the short chain removal. So what we do is we have a 3-chambered unit, right? And there is a membrane separating each of the chambers. proprietary system. This is all patented. Anode, cathode. Water comes in, naturally migrates towards the anode. That electrolytic field actually creates a stronger pull, and we capture it onto that membrane. That membrane capture is strong. It won't come off. We have tried. Even in our FATE studies, we had to dissolve the membranes. So what we do after that is we take it back to our facility when that membrane module is used up. Take it back to our centralized facility. We'll take the membrane out. We'll destroy the membrane through another patented process, put a new membrane in, and that module goes back out into the field. We create on site about 1/42,000th the waste of a carbon system. Okay, million gallons of water treatment for activated carbon is 80,000 pounds of waste plus water weight. Our system produces 2 pounds. And then we take that 2 pounds and we destroy it.
So it's not bioaccumulating anymore in the environment.
Not bioaccumulating. We're removing it from the environment. We're turning it into an inert salt.
And that's kind of like you guys is kind of one of the things you're out to get is like, okay, like sure, the activated carbon removes it, but it doesn't destroy it.
Correct.
And you guys are trying to come in and just.
Yep, you have to take that. So they're a collection technology. We're actually doing collection destruction.
Got it.
So there's a few of us in the industry, but not many right now.
Collection and destruction. And a big part, you mentioned earlier, like, so you break it down, but then it's not detectable.
Yeah, a lot of the technologies that do destruction are doing incomplete destruction. So what they're doing is they're cleaving off what they call a functional end and creating two small chain PFAS out of a long chain. So few technologies, things like supercritical water oxidation, will actually break it down into ions, but then you have to make sure that when those ions balance again, that you're actually creating inert salts instead of something worse than what you started with.
Got it. Okay. Yeah, so essentially they're just doing enough to pass the test right now. They're not really being the A+ students.
Some of them, yes. Some of them are doing great and doing what we do, but destruction also comes with a very high price tag.
This product was developed for the founder's father who was sick. That's where this all came.
That's where this all started.
100% safe.
Yep.
What makes it safe?
It's an iodidated compound.
Iodidated.
So cuprous iodide solution. So our Cupridyne Clean product, again, started, I believe, somewhere over 10 years ago. It started with our founder and wanting to help his dad. But we actually, when our bosses took it over, they expanded into the solid waste industry. Now, this technology, the backbone of this technology also has an FDA 510K clearance and is a wound wash for surgeries that can be left in the wound bed and not have to be rinsed out. So that's something that's incredibly rare in the medical industry, is a wound wash that doesn't have to have a rinse afterwards, but it'll keep removing bacteria in the wound bed for up to 5 days. So it's that safe. If you ever seen the Poof commercial on TV for pet and odor control, you'll see him actually spray it into his mouth. That is actually truthful. You could actually take this and you could actually put it in your mouth. It's 100% safe. It's safe for pets. It's safe for the planet, as they say in the commercial. But it seriously is 100% natural. It's made from a copper sulfate potassium iodide solution. So we call it cuprous iodide. And it will remove H2S, ammonia, mercaptans, amines, VOCs, and BTECs on contact.
Wow. So how do the clients rave about it?
They do. It is incredible how fast and easy it is. It's typically applied through misting systems, which we also sell, but it can be put into a backpack sprayer and spray drains down. I have clients that actually buy it and spray their trucks down with it because, you know, at the end of the day, sweaty guys, sweaty girls come back in there. They spray the interior of the truck down to get rid of all of the nasty odors. People spray their gym bags down with it.
You're giving our ideas.
Yeah, absolutely.
Cool. That's Cupridyne.
This is our third technology that we have here. It is our advanced oxidation system. Now, we differ from other advanced oxidation systems because the oxidation systems typically use hydroxy radicals, meaning they've got some kind of ozone, peroxide, some chlorine, something coming in that's creating speciated hydroxy radicals, oxygen, hydrogen. We use a little bit of that coming from the water, but we actually use potassium iodide as a precursor. And so as that comes in and mixes with the water at each stage of this technology, we've got what they call a packed system. So there's a carbon substrate and there's a electrode on either side of it. When you hit that electrode going across the treatment technology, we get a rapid drop in pH and then a rapid rise in pH, and you get all these great iodidated species along with the hydroxy radicals that have this great amount of oxidative power. So it will take pharmaceuticals out on contact. It will do a 6-log reduction on bacteria in a single pass. We're able to take some organics out. It's just an incredible technology. Now, this is going to come more into play as we get further into that total organic fluorine, because pharmaceuticals have those organic fluorinated compounds. So we're going to end up looking at this on wastewater to meet some of those new regulations. But Europe's been regulating pharmaceuticals in wastewater for years, and we're just starting to catch up.
In the States with regulated. I did talk to someone earlier today. It was pretty interesting. They said, we're making this push for getting the PFAS out of the drinking water, but they're like, what about how it's coming into the system to begin with? It's getting all condensed into.
There's a lot of work being done actually by the EPA on some of the manufacturing processes, taking it out of the manufacturing processes, out of the consumer goods. We're starting to see states pass consumer product bans. Things you don't realize that have PFAS in a waterproof makeup, guitar strings, fabric softener. These are all things that contain PFAS. Dental floss, your contact lenses, if you wear contact lenses, are PFAS. PFAS is what made plastic bend.
What makes it bend?
It's what makes it bend. It's what they use to keep the nozzles clear and blow molding of plastic. So your plastic bottles, things like that. It's used for manufacturing processes to help with the slippage. So like Ziploc bags don't contain PFAS, but it's used in the manufacturing process of Ziploc bags. So there's consumer product bans in some states. 3M has actually announced that they won't make the polyfluorinated compounds anymore after, I believe it's like 2026, but we'll see what they replace it with. And we'll see how many.
Is the solution worse?
Well, what's going to happen is we started off with 6 compounds. The EPA is going to expand that out. It's more regulations coming. This is just the tip of the iceberg as these regulations are coming.
Real quick, where is this used?
So this one's used in wastewater. Our AEC can be used for PFAS, can be used in water, can be used in wastewater. We've even had some very effective leachate bench scale trials. So we're moving into that arena. The odor control is used in wastewater. It's used in the solid waste industry, but really it's used anywhere you have odors.
Where you have odors. Okay. That's awesome. I think that's all I've got. Where do people find these products?
So the best place to go to find is start with our PFAS product. Go to our website. It's bestpfastreatment.com. And from there, if they're interested in some of the other products, there's an other products tab and they can find all of the other products as well.
Okay. Awesome. Thanks, Tanya.
Thank you.